Our next speaker is Cosmin Pintoiu. He's a solution architect for Bigstep, and real-time interactivity at scale is the topic. So please, let's welcome and listen. Thank you.
Thank you. You hear me okay? I'm back? Great. So first of all, great presentation, Daniel. Yeah, awesome. Awesome. You raised the bar a little bit too high. Sorry. Okay, let's talk about data sharpening and real-time interactivity at scale over large data sets. A few words about myself. Most of my experience was in the banking industry, where I've designed and implemented message processing systems for a couple of years. And now I'm currently focused on large-scale and real-time implementations. Let's take a look over the agenda. I know this is the last presentation, and I was hoping to say, bear with me, there will be beer and wine, but there's going to be a gap of half an hour until there is. Okay, so I'm going to talk a little bit about real-time and the motivation behind. Then the different layers involved in creating such a real-time system, from ingestion layer, decoupling, persistence, and serving results to a visualization tool. Okay, so why real-time? A lot of data that organizations are capturing and analyze, perform ETL, actually starts out as streams of data. So there are a few examples: retail point of sale data, telecommunication, network, traffic, air traffic data. Well, it makes sense, given the fact that there are a lot of open source software that you can perform this type of analysis in real time, and that runs on commodity servers, meaning that even the smaller organizations now that have capacity to do this kind of analysis, it makes sense to take a look on that data as it comes in. So skip the batch processing and move towards streaming data and analyze it. So some decisions shouldn't wait for the batch processes to complete. The other interesting thing that I came across a while ago was on a blog post, I think from Cloudera, was about businesses and their assets, and how assets are depreciating over time, which makes sense. Let's think about our cars or trucks or different equipment, electronics. While we use them and extend their usage, they are depreciating. And we might be tempted to say here that it's not the case with data. Data is not one of these assets, but we're wrong. And data actually loses its value when decisions that depends on it are not made in the right window. Meaning that, let's see a few examples here. Preventive maintenance. If you're not looking at that data when you need, let's say, even for a car or jet engines, or let's say you're not taking advantage of a market opportunity at the right time. Or I think there was one more example here. What I want to say, real-time data and real-time analytics actually brings your business to its full potential. Okay, so it's easier for me to talk about a specific use case. This one is a retailer that wants to integrate its point of sale data. So point of sale are transactions that are created when products are scanned and scanned at the cashier or self-scanned. Integrate them with historic information that is it's captured for a couple of years, and also want to integrate this with different budget data, stock, warehouse, and so on. Basically to get a competitive advantage. And let's see a few examples here. You can have a basket analysis. You can look at trend analysis and seasonality trend analysis. This is an example. It's actually a GIF, and we're seeing how, let me see. Here we're reading data, and dashboards actually sharpens. We're looking at 50 million top. Here are a few hundred million records. And this is the actual speed that this dashboard is rendered. This is a select for a certain category. We're looking on this particular use case on billions of rows and a few terabytes of data. What is more important is that you have interactivity here. If you right-click on any of these products, you can change the question you're asking. And while this is reading the data from your cluster, you can actually ask a different question, and so on and so on. Instead of waiting, let's say, for this volume of data, 15 minutes to read the entire data with a small to medium cluster, you get instant results. I think we'll get back to this Zoomdata. One more important thing is that we're looking over real-time transactions. So we have on the same data store this historical transaction over the last 5 years, let's say, but we're also adding transaction from today, which is pretty awesome, right? Okay. I've been the moderator on the architecture track for the entire day. And I said, okay, let's not bring architecture overview on this one. There weren't so many dashboards and diagrams on the other track. So let's see the system. We have point of sale data from the source, also historical data that you probably want to push them in batch and other data sources. But we are creating pipelines of data through a VPN and push them into a Kafka cluster. Then we're syncing this data to Kudu, which is a data store, distributed data store. And using Impala, which is a query, a SQL query, we are serving data to Zoomdata, which is a data analytics and visualization tool. Now, I know there are a lot of products. I hope this is a little bit technical. How many of you heard of stream sets? I know 2. Okay. So let's see a flow overview, and I will briefly describe stream sets, Kafka, and 5 minutes I'm going to talk about Kudu and Zoomdata, because these are the components that actually bring us this interactivity. Okay, stream sets, this is a straightforward flow. Stream sets is a low latency data ingestion tool that allows you to create continuous data pipelines. What is important here, it has a record-based approach, meaning that you have a schema and can perform different cleansing operation on the data, where you are pushing it into your cloud or cluster. Kafka, on the other hand, is a distributed publish subscribe system. What does here, it offers the initial persistence of the data. So your data is now persistent. It also offers the decoupling of the entire infrastructure. Instead of tight coupling this component with Kudu and serving only one purpose, we are decoupling with Kafka, and you can have different consumers using this data for different other operations. Also, you can anytime change something here, and your data will be persisted. Again, I'm using a stream set pipeline from Kafka to Kudu because it has an easy-to-use connector. You can create actually your own application there. Okay. And this is a particularly important slide because, one, we're almost halfway there. So, second, Kudu is the central piece for this interactivity. Apache Kudu has been developed initially by Cloudera. Now it's an open source Apache project. It is a data store that is positioned between HDFS, which is, I think, how many of you heard of HDFS first? Okay, okay. And Apache HBase. What Kudu does, that offers a balance between high throughput reads on large volume of data, fast scans, and low latency access to the data. Also offers mutability to the data. You can insert, update, and they positioning it somewhere in between these two products. I'm not going to talk about different components of concepts and architecture of Apache Kudu. I'm going to just mention what Kudu is not. Kudu is not a file system like Parquet is. It's a columnar-oriented data store, similar to this one. This is why it gets all the benefits from read efficiency and also columnar compression. is not an application on top of HDFS like Apache HBase is, and most important, is not a replacement for HDFS nor for HBase. Basically, you still have to analyze your use case and use the right product. Okay, this is the right time. What I want to talk here is something very important for developing a performance system. It is similar to a relational database, and I think we're all familiar with them. You still have to pay attention to your schema creation, column design, your primary key design. But what is a little bit different here, being a distributed relational-like data store, it's the partitioning strategy, which is a little bit different. And here are some trade-offs that I want to mention when you are planning to use or using Kudu. Kudu actually has two types of partitioning or sharding, by hash and by range. And what is important is to understand your data model and your expected workload. Because once you do that, imagine you have your application which is very write-oriented with a lot of throughput while writing. Then you would want to partition your table into multiple tablets, meaning that you will avoid overloading a single tablet. Tablets here, I think I skipped that, are how you are statically partitioning the data. And if your application performs a lot of short scans, fast short scans of data, your bottleneck will probably be somewhere in contacting these different tablets. In this use case, you would need the data to be only in one tablet, right? So understanding a few of there are a few pages of explaining how and what strategies are best for different use cases on their page. It's critical for designing a performance table. Here on the right, we have a create table statement. It's important to understand the primary keys have to be in the right order here. I'm also distributing by hash and by range. Range by years and hash by ID. Distributing by hash has the effect of distributing the data into different buckets equally. So you have a lot of throughput at writing, but as well as reading. Distributing by range on these years means that when you're asking a specific question for, let's say, a year, month, or a week, it will not scan the other tablets that does not have the respective data. So if I'm asking only this one, I'll get 4 buckets here that will give me the answer, but I'll ignore these 8. Anyway, with the right distribution in mind, we get something like this. Here we have almost 12 gigabytes scanned per second cluster-wide, which is a small cluster with locally attached drives. I'm going to talk about them. Later on, I was able to achieve somewhere around 15 gigabytes per second. And imagine this over a few hundred gigs of data or a few terabytes. It gives you an almost instant answer. OK, back to Zoomdata. How many of you heard of Zoomdata? Yeah, 1, 2, 3, 4. OK. It's a data visualization tool and a BI tool. It's very performant on real-time workloads. It has a lot of connectors here. I think we are familiar with some of them. It has this fusion connector that can bring different data from different data sources and see them as a single table without actually transferring data. What we are using is Cloudera Impala and Spark SQL. Back to Kudu. Kudu is just a data store, so it has no SQL capabilities. You still have to use a query engine like Apache, like Spark SQL or Cloudera Impala. I am using Impala because it's tightly connected. Their developers work on both projects, even though now they are open source. Having your time attribute in your table allows you, and a specific format that it is accepted by Zoomdata, allows you to enable live mode, which we saw in the GIF. Also on the left side, we have different types of charts. The resolution, I don't think it helps me too much, but basically it's what you will be expecting to have in Power BI, Tableau, or Click. And also here we have a playback feature, which basically lets you replay data from a previous day or previous week with different speeds. You can change, okay, give me an hour per second inserts and renders your data. And sharpening. Sharpening is something similar to loading a large image in a web browser. Initially, you get a blurry image, and as data loads in the background, it sharpens. Well, this is what they are doing with the queries. They are breaks the queries into micro queries and send them to data nodes, to Impala, and ask the question and get initial results in seconds. Then renders a chart that keeps on sharpening as data arrives. There is a prerequisite for this feature to work. Your data has to be partitioned by a time field, basically because it's going to ask different time slots. So what it does, actually, it works like a statistical database. So it will give you an overview from the beginning, and then it sharpens. Let's say I'm looking over 10 billion rows. That's going to take 30 minutes to do a full scan. But if I get this image from the first 3 minutes, and I'm only reading, let's say, 15%, I can change that. Okay, I don't want that. I don't want to lose the entire hour. Let's get back, or let's dig deeper. Also, if Zoomdata, they advertise as being the fastest visualization tool on big data that actually works. If they can return the results in a couple of seconds, then they're not going to go to sharpening. They're just going to render your chart. But if the 10% rules actually say that if your time bar, it's let's say 5 years, and you're zooming into weeks or days or even month, which falls under the 10% rules of your time slot, it will go and sharpen your data. Now, the infrastructure that I run is, again, there are 6 billion rows with almost 6 terabytes of data. It's in Bigstep bare metal cloud. This is the infrastructure control center. Here we have a Cloudera cluster. This is the VPN tunnel that I was mentioning at the beginning. And here is my Zoomdata server. The nodes that are actually allows me to read this data with that speed are, I don't know, let's say 20 cores with 128 gigs of RAM. Are these medium Hadoop? Is that a lot? Is it not? Important is that you can easily scale these nodes. If you're planning, let's say, okay, let's go there and bring the entire data set. We have 10 years of data. And a few general takeaways. The simple design, as I said, the flow was quite straightforward. Understand your data model and the expected workload, and take into account your scalability and structural changes. And I think I'm a little bit ahead of schedule. So a few minutes of questions. I think it was a little bit more technical than Daniel's. And my energy wasn't at his level. Okay. Yeah?
Technical question. So the Kudu, how does it compare to Cassandra? It seems like that's very similar to tuning capability and so on. These are the benefits. One over the other.
Yeah, well, I was performing some tests last week on a similar cluster on Cassandra. And it is actually designed for a lot of writes. Cassandra, this is its thing. It's good at writing. But when it comes to read throughput and surfing results, Kudu, it's actually more performant in terms it's columnar, and it gives you analytical speeds over the data. And I think this is the major differentiator. We can dig into. Yeah, for just reading certain columns, not the entire row. Yeah. Okay. I'm glad I do have some people here. I know we're all exhausted. Okay, I think this is it. Thank you.